Okay, so I'll do the Maclaurin series here. So I start taking derivatives. First derivative, product rule. I get cosine of x minus x sine of x. Second derivative, minus sine of x, and then I get a product rule. Sine x plus x cosine of x, giving me minus 2 sine of x minus x cos x. F triple prime is minus 2 cosine of x minus product rule cosine of x minus x sine x, which is minus 3 cosine of x plus x sine x. Let's do one more. Fourth derivative is 3 sine x plus product rule equals 4 sine x plus x cos x. All right, let's take these. So I see a pattern emerging already. Got 2, 3, 4, and some pluses and minuses, and some trig going on there. So from this, I'm doing Maclaurin, right? So that is the, what was that, the second derivative with 2? Yeah, second derivative. So the second derivative with 0 plugged in is going to give me 0. Okay, because it's 0 here and then 0 there. And then the third derivative with 0 plugged in is going to give me minus 3. Then the fourth derivative with 0 plugged in, give me 0 again. And I feel like that's not enough information, so I'm going to go back and do another derivative just to see if my hunch is correct. So fifth derivative is 5 sine x plus product rule x sine x, showing it 5 sine x. I made a mistake somewhere, haven't I? What have I done? Dude, this should be a cosine. Trying to go too quickly here. So I got 4 sine x. So if the derivative is 4 cosine of x. Five cosine of x minus x sine x. Yeah. Okay, now if I plug 0 in there, I get 5. Zero is 5. So looking at these 4 data points, I deduce that the nth derivative with 0 plugged in is, well, that's going to be hard. If I go with n here, that's going to be, because, half of them are zeros here, it's not going to be easy for me to figure out. So what I'm going to do instead is say that it's the odd numbered derivatives that are non-zero. So why don't I say f to the to n, doesn't matter, to n plus 1, let's say. With 0 plugged in is going to be, well, I have the same number here as I do here. Okay, so that tells me I'm going to have a 2n plus 1. And then I got -1 to the power of, it's either going to be n or n plus 1. If I look here, n is equal to 1, and I get a negative. So I want just n there. So where was I? Okay, you can also say that when you look at the odd derivatives with 0 plugged in, you get 0. Okay, so Cn, in my case, is f to the n with 0 plugged in divided by n factorial. Which is -1 to the n times 2n plus 1 over well, no, I've made the same mistake again. I need to do something else here, right? I need to go not n, but I need to do c 2n plus 1 rather. Oops, c 2n plus 1 is and this should be so this is 2n plus 1 factorial down here. So what happens? You get a cancellation. Okay, because on the bottom you have 1 times 2 times 3 all the way up to 2n 2n plus 1. So that cancels with that. Then I got -1 to the 2n plus 1 all over 2n factorial. Okay, this is c 2n plus 1. And then also, of course, c 2n, the even number terms are 0. So my Maclaurin series is, it would be from, it would be, say, from m equals 0 to infinity of Cn x to the m, right? That's my Maclaurin series. Okay, but when m is even, you get all zeros. And when m is odd, you get the non-zero terms. Okay, so this is, all the terms, even and odd. And then here I'm writing just the odd terms because the even ones are going to end up being 0. And what did I get? N equals 0 to infinity. What was my coefficient? It was it 1 over, no, -1 to the 2n plus 1. X to the 2n plus 1 all over 2n. Factorial. Well, let's see if I got that even remotely correct. I feel like I've made a mistake, but let's see. The same, so something's gone funny with my. So if I'm looking in the answers here, I see that my alternating factor is funny, not funny, haha, but possibly wrong. Yeah, that must be wrong. I know it's wrong because that is an odd number, saying that I'm always getting negatives. That can't be right. So let's see what my mistake came from. Aha. The original sin. I see it now. It first occurred here, I believe. Okay, I was looking at these numbers here and I was saying, oh, I just copied it wrong. So that, okay, I had it correct. This was correct, but I copied it wrong right there. Okay, so that was just a copying error. Should be an n. That fixes it. -1 to the n. Okay, so that's my problem. N, n, and n. There we go. There's my Maclaurin series.